Hey everyone, welcome to my channel. And how are you guys? Do let me know from where you're joining, and if you have any queries, this session about the scaling masterclass. Okay, let's see. I think okay. Yeah, do let me know if my voice and video coming on all fine. Suddenly my original internet gone down, so I had to use the backup one. So yeah, do let me know if you are able to see me, hear me properly, and all that. Let me check quickly. Mm, yeah, I think you guys got the notification now also. Yeah, people are joining. Okay, so without any delay, I will start the session, and it's about all the basic and advanced scaling concepts, and including the Kubernetes and containerization, of course. So let's get started. Let me check. Yeah, Wi-Fi anyway not working. Okay, so let's get started. So first thing, let's talk about this. Okay, what exactly is scaling? Okay, now of course scaling in the sense. Okay, we have one server, then suddenly there is a sudden increase in the request and load, and you are adding automatically or maybe manually you're adding new servers. That's what traditional scaling that you can think of, but in actual production it's not just that. Okay, there's a lot of things goes beyond just adding the virtual machines. Okay, just let's go over a very quick uh, misconception and actual reality very quickly. Okay, I have shared this particular kind of the sheet to in the LinkedIn already, but yeah, just a quick recap. So yeah, scaling is not just about adding the virtual machine. It involves scaling the entire architecture, not just virtual machine, but scaling storage, scaling databases, scaling maybe cluster, the cache cluster, scaling the message processing. Every single component that you have in your cluster needs scaling, not just a virtual machine. Okay, then is the scaling about only handling more traffic? Actually, no. You might not have that much of a traffic, but maybe your customer need more data, your customer need more storage, needing or adding or maybe decreasing, increasing all these things. All this falls under the storage scaling, but that's also a form of scaling, isn't it? It's not just about only traffic, but it's all about the storage and database, just like I told you. Okay, now, is more resources always lead to better performance? It's not true, because you have a very bad application code that's running in the server, and you're hoping just somehow if you add too many instances, it will not magically make that particular application performance very well. Okay, so it's not practically mean that if you add as much as is possible, your application will perform faster. No, the application that you develop, it has to be optimized. Okay, it have to be tested very well. The queries that you're making in the database, the queries has to be optimized. The indexes that you have in your database, those indexes needs to be optimized. The database that you're running, or maybe the caching that you're running, that has to have enough resources, that has to be optimized. So every single component need to be optimized. It's not just the adding more resources, it's about application and the configuration as well. Okay, now, is scaling is one time effort? Never. That, like, if it would have been only one time effort, then why wouldn't any engineer for years, right? You would have fired within maybe 2 months of your doing the initial work. It's not like that. It's a continuous effort. You're adding resources, you're optimizing it, some version change, some upgrades happening. Based on that, you are kind of updating the configuration of scaling and all that behind the scenes. A lot goes on, and we'll be discussing all that as we move forward. Okay, then any architecture can scale? Of course, no. It's a big no. Why? Because then, if that would have been true, then why there is a need of microservice architecture instead of monolithic? The monolithic was one of the very problematic architecture where it has been very kind of problematic to do any kind of scaling, because all component has been in a single cluster, single virtual machine, and it's kind of impossible to scale. Of course, you can do vertical scaling, and what is vertical scaling? I will come just within few minutes, but that's not enough. Okay, so the any architecture cannot be scaled. The architecture, you have to plan for scale. That is more important. Now, adding load balancer will solve all auto scaling problems? Never. See, load balancer, what it does, you have a load balancer service, or maybe application, or maybe hardware, whatever it is. The traffic coming to load balancer observing. You have maybe 3 virtual machine or 10 virtual machine, and it's maybe based on the strategy that you implement. Maybe it's a round robin, maybe it's a maybe IP hashing, maybe it's some weight based, or maybe resource based. You have kind of forwarding the traffic. And what are the strategies? I will come to that also, don't worry. But you have a strategy to distribute the traffic. It's just distributing. Scaling happens when you again say scaling not just about the virtual machine, but includes the compute, the storage, the scaling, the network, everything. Based on the requirement, it should increase, and when there is not much requirement, it should decrease. Okay. Now, is CDNs are only for the large enterprise? No. Even practically speaking, I have worked for clients who are not that big enterprises, so just small startups. Still, they want performance. Still, they want the content to be delivered to their customer as fast as possible. Within, of course, they have the budgetary constraint, right? And that is okay. There are many CDN solutions available which are cheap, and they are utilizing actively. The startups are actually utilizing. So, CDNs are for everyone. And if you are thinking of scaling your static contents, okay, your static site, your static contents, or maybe images, videos, all the HTML files, that can be served as fast as the customer, so that the customer, see, the CDNs, one of the very magic of CDNs, it's not you handling, it's most probably a CDN service, right? So that way it will be much more faster, and you don't have to think about the scaling. Of course, there is a negative point. If they fail, you also fail. But there is a SLR there are kind of guarantees are there. It will be uptime maybe 99.999%, that kind of thing. Okay. Now, can you always rely on auto scaling? Again, no. Auto scaling there, which is good. You need it based on your requirement. It should add more resources. Based on you don't require resources, it will automatically remove the virtual machine, or remove the instances. But if you have bad application, auto scaling cannot make it a good one. So the application that you're developing, that you have to optimize. The database queries are making, that you have to optimize, that you have to make it faster, and all kind of configuration you have to optimize to get this kind of ideal performance that you want. Okay. Now, I have talked about what about the misconception. Now let's talk about what is the real scaling means. So the real scaling means the ability of a system, application, infrastructure to handle increased load or demand by adding resources and optimizing the performance. It's not about the adding resources. It's about plus optimizing the performance. Okay. Otherwise, you might think, okay, I have 100 machines, 100 virtual machines. Why the application still loading slow, still having so many problems? Maybe the front end that you have developed, that is so heavy, you didn't optimize the production. You didn't minify the script file. You didn't generate the static HTML files. All kind of optimization you have to do to achieve the ideal scaling that you want. So it's the infrastructure plus the application performance and many other things. Okay. Now, what about the types of scaling? There are many types of scaling. Okay. As I say, it's not just about the virtual machine, right? It's about application, infrastructure, right? So let's talk about the types of scaling. Okay. So I think you guys already know about this, but let's go with the compute scaling. What are the compute? The CPU that you use, the RAM that you use. I mean, you have any application, and any application that you have developed that you want to run require some amount of RAM, some amount of CPU processing power, right? That we are calling the compute scaling. Okay. So how can you what are the different types of the compute scaling? There is mainly two types. Okay. First one is the vertical scaling, and second one is the horizontal scaling. Let's talk about the vertical scaling first. So what is the vertical scaling? Now, vertical scaling, or we call it the scaling up. Okay. This means that increasing the capacity of a single server. Okay. So it's not by adding more server. It's just whatever server that you have. Maybe you have one server, you have maybe 2 CPU and 2 GB RAM. you need more CPU, you're just changing that 2 CPU into maybe 4 CPU or 8 CPU as per requirement. Maybe the RAM is very low, your application not able to perform well, you are making that maybe 8 GB, 10 GB, 16 GB, whatever is the requirement, you are making that change. That we call a vertical scaling. Okay, or it can be storage also. Maybe you have 20 GB of storage on this hard disk that you want to increase to maybe 20, 30, 40, whatever is the next amount that your application require, or what you need. Okay, that part. Now there are many use cases, of course, not like the thing is there, right? What vertical scaling is there, that means there's a use case, right? So what is that? The use case, for example, you have a database virtual machine, okay, and that might require, for example, you started very small and it is performing well. Now you have more customer base, their request, the more load is coming, the more requests are coming. In those case, okay, you need to increase that. Now the problem or the negative part here is that since you are kind of upgrading your existing machine, the problem you have to, in most of the cases, you have to take down the server to do the upgrade, right? And that cause a service downtime, okay, which is not ideal for production environment. So vertical scaling is good, but it has its own share of cons and negative points, okay. So, and that can be, of course, there are solution also which can be avoided. So you can have failover instances or backup instances. When you are upgrading this particular instance of this particular server, you first switch it to a standby server which have the same data storage, and maybe somehow you have a replica of the latest database backup kind of stuff, and then you take down the old server that you want to upgrade, and after the upgrade is done, you again switch back to the upgraded server. Okay, that is one way to handle, which called failover mechanism. Now the second one is the horizontal scaling, and we call it the scaling out also, and this is by far the most used scaling mechanism in production or most of the places where you have deployed the application. Okay, now what is horizontal scaling? Horizontal scaling is adding more machines or more virtual machine or servers to your existing infrastructure to handle the increased workload by distributing the task between the multiple nodes. So for example, you are running 10 servers, okay, or 10 virtual machines, and you have maybe 10,000 requests coming. Suddenly you're running sales, or maybe some Black Friday happen, or maybe some particular event happening. Then you know that, or maybe you pre-planned, or maybe you have said auto scaling. We'll come to the auto scaling, that you need 100 instances, or maybe 50 virtual machine or instances. You're adding that much of additional instances to distribute the workload. Okay, then particular that scenario we're calling the horizontal scaling, where you're adding like new virtual machines to distribute the traffic or workload. Okay, and again, this is the most common one. What are the use case? Like most of the say web application, distributed system, microservices environment we run using this horizontal scaling only. Okay, now and this is you can see the reference to the images, like adding more like first vertical scaling was adding like bigger, like making the existing one bigger. For the horizontal scaling, just adding new instances. Now auto scaling, which is very interesting one. Okay, auto scaling is, for example, same scenario. Okay, you have for example 10 instances which is handling maybe 1000 or 2000 workload. Suddenly one leg request coming, so you are sleeping at the night, for example. Okay, then how it can be scaled? You cannot add manually all the servers, right? That is why auto scaling services and systems are coming, which will automatically, okay, they will check. We have 10 instances. 10 instances, average CPU is usually run maybe 30% or 40%, maybe 50%. Now it's suddenly every single instance average CPU reaching to 80%. And if it reach maybe certain 90% or 100%, then they will not able to serve any more request. Your services will definitely go down. What auto scaling does, you have to check, you have to add certain trigger points, okay, alerts. If average CPU reach 80%, it should add more instances, maybe 2 instances, maybe 3 instances, based on your workload, your traffic, you know how many instances to add. Okay, and it will keep adding unless it down to maybe 30% or 40% or some percentage that you think your application should perform well. That we are calling auto scaling, and it's not about like adding instances. For example, that load is gone. I mean, that sudden 100,000 requests are gone. It's maybe only 10,000 or 30,000. Then, as the load or request counts come down, it should automatically remove the instances. Okay, and that again you can add point, maybe if instance CPU load going down less than, for example, 10% on 5%, you don't need that. Okay, and of course you should have minimum kind of desired and maximum count, which is, your service got at least 5 instances. So no matter scale up and down, you constantly there should be 5 virtual machines should be running. Those kind of configuration you have to kind of give as an input to the auto scaling services. Okay, this is all about the compute scaling based on your requirement. You have, I mean, most of the cases, I think if you're running a web application or any application, altogether, except database I will come, of course, within, I think next one is the database. Yeah, next one is database. We'll cover the database scaling mechanism and how it's get done. But for compute, this is the way you can do the scaling, or you can handle the scaling. Okay, let's see, any questions so far? No, but yeah, if any question, you can go ahead and feel free to ask. I will definitely answer. Now the next one is the database scaling. Okay, now database scaling is a special one, and I will, of course, will definitely cover in depth. Let me see if any question. Okay. Okay. Yeah. So yeah, as you go forward, if you have any question, any in-depth question, any small question, no question is small, I will say, but any question you can go ahead and ask. Okay. Now, let's talk about the database scaling. What is database scaling? Now, you see, there are many kind of database engine available. Maybe MySQL, maybe PostgreSQL, maybe, for example, there is like lot of other things. Say Oracle, many kind of databases available. But those databases ultimately runs on machines, maybe physical machine, maybe virtual machine. For us as cloud engineer, DevOps engineer, we have to run all those databases. If it's a managed one, that's managed by the cloud service provider, but majority cases you also have to manage those databases, right? And if you're managing those databases, maybe it could be MySQL database, PostgreSQL database, could be MongoDB, whatever it is. If you're managing the database, you have to also manage the complexity of the scaling. Okay, and just like compute part, because ultimately this database engines are running in a virtual machine, right? That means you have to first prioritize their the compute part, because like database is utilizing the all the CPUs, all the RAMs and storage, right? So based on the particular database that you're going to run, what kind of architecture is support? Is it support vertical scaling? Then do it. That's the most thing you should go after. If that particular database engine doesn't support the ideal this vertical scaling, or say ideal horizontal scaling, then you have to switch back to the vertical scaling, which is the not so preferred, but somehow you have to do it. Okay, now what is the vertical scaling for in terms of the databases? So vertical scaling for databases involve increasing the resources of a single database server, such as maybe adding more CPU, memory or storage. Okay, and the most common part I see, the traditional database, when you're maybe running older version which doesn't support, or maybe there are some database even newer version doesn't support the scaling part. So you have to, if you want to increase the performance, or you have to add more like store more data, or you have to kind of run the queries faster, you ultimately have to do vertical scaling, which is by adding more CPU or RAM, or maybe the storage part. Okay, for increasing the IOPS part. Now that is there, which is the vertical scaling. But again, your first priority should be a database. I mean, when you're planning a database, okay, for your application, you should of course first check the performance part, the EC2 integration part. But Thinking about the future, you also have to kind of design such a way that it can scale based on number of the users you're adding, the active workload, the data is getting stored, retrieval part, the queries it should be faster, all this kind of thing you have to pre-plan. That way your life will be easier and not in a hell, honestly. Okay, I've seen so many clients whose lives, I mean, hell, like they're making one simple query and it's taking 2 minutes 3 minutes to fetch the data. And think about the normal user who is waiting for the data and waiting and think like this is a shitty app and nobody should be using this app, and they're giving a bad review in the maybe Play Store or say iOS App Store, right? So you don't want, I mean, as a developer, or as a backend engineer, or maybe as a company owner, whatever it is, your ideal should be having a database that gives the response as fast as possible. Of course, you cannot make it easy way. You have to optimize the database. You have to be like, even it's a managed database, okay, you have to optimize the data, otherwise it's very hard. Now for optimizing data, I will come to that, but let's just go with the basic concept first. What is the horizontal scaling for the databases? Okay, so horizontal scaling for database by adding more servers or node to distribute the load across multiple machines, but have the like, now the other thing is that you're adding more machines. That means a bit of complexity, the data replication things are there, the data read write, synchronization, all this complexity getting added. Okay, so to handle that part, there is two things: shredding and replication and partitioning. Okay, and I will try to, I mean, I will cover all three one by one. First, let's talk about the database shredding. So what is a database shredding? So shredding is a form of horizontal scaling where the database is divided into smaller and more manageable pieces called shards. Each shard is an independent point. Note the point. Okay, each shard is the independent database, and together they complete the dataset. So if you are planning to use sharding, I mean, a database that has a sharding, you have to see what are the databases that support the sharding. So there are like MongoDB, Cassandra, Elasticsearch. These are the databases, NoSQL, like majorly the NoSQL databases which natively support. Of course, there are like, for example, PostgreSQL, MySQL support, but that required additional overhead, additional configuration. I'm not going to that way, but natively supported by MongoDB, Cassandra, and Elasticsearch, which is majorly in the NoSQL database. Okay, because it's a schema-less. And this database help you achieve that the addition, like scaling the better performance by shredding, and of course the performance get better, and you can have like, if your requirements are coming, you need more research, you can add more shredding, right, or more shreds. Now it's ideal for large dataset where the data can be easily divided, such as multi-tenant application or high volume web apps. For example, users can be divided by the geographic region or account type. That you can think of, you can just think of a virtual divide of the data and store it somehow. Okay, now let's come to the replication part. What is replication? Now replication involves copying that data from one database, which you can think of like, for example, you have the main database where the writes are happening and reads also happening, the main server, but your application is read heavy. So more than the people, like, or say your developer write the data into the database, it's the number of people that query your database, or say they want maybe a web, you have a, for example, e-commerce site, okay, where mostly people see the things first, like lot of people are seeing the pages, they are checking out the deals, all that. Like this is a read heavy application, right? Happening when you are adding your backend, you are adding the content, the products, which is happening eventually maybe daily once or twice or maybe monthly based on your scale of your business. Now those use case, it's a read heavy, people are checking out your page more, right? Those cases, if you see, there are a lot of traffic coming and most of the requests are the read request. So you can add the replicas of the, or the read, we call it in the more simple language called read replicas, which is ultimately syncing up with the master database server and copying the data into the replicas. And when you're requesting the data, you're not requesting to the master node, you are requesting to the this read replicas, or there are even advanced mechanism available which will sit in front of the read replicas and the write replicas. It will check, is it a read query, is it a write query? Write query, it will send to the writer node. If it's a read query, it will send to the reader node, okay, or reader replicas. That way it can achieve this kind of better performance, better query. For example, normally you have a single virtual machines, which is single instance, I'm calling it single virtual machine, which is a reader and writer. Okay, so which means it's writing the data into data storage and reading the data from the data storage. Okay, that means if more read requests come and write requests come, it will become overloaded. But if you have this kind of replication, you should have a cluster. Okay, you have a cluster where you have the writer node or writer virtual machine and reader virtual machine. Then if you divide, like for writer, any write request coming or write call coming or write query coming, it should go to the writer node, and any read request coming, it should go to the reader node. You might have hundreds of reader nodes or only 2-3 writer nodes. Based on your application architecture, you have to decide that part, but you have that kind of architecture. Then that will be faster reading response, right? You don't have to wait. The server will not get overloaded because you're distributing that read query between the different servers or different replicas. Okay, now it's again just as a recap kind of stuff, a quick recap. It's suitable for the read heavy application where the read operation can be distributed across multiple replicas, like content management and say e-commerce application also, where it can be utilized. Now, what are the DBs that support this replication natively? MySQL, PostgreSQL, and MongoDB also, and Redis, all this database server. Now, Redis is a cache server. We'll maybe discuss a bit more later on. But these are the server engine, database engine which support the this replication natively. Okay. Then let's come to the partitioning. Now, you might sometimes kind of get confused between what in shredding part you told me that it's kind of partitioning, right? Then why you're asking about partitioning separately? It's a bit different. Shredding is actually kind of in actual storage. You're storing in a divided way, okay? But partitioning is a logical partitioning. So let's go with the definition first, okay? So partitioning involves dividing a database into parts based on the specific criteria, such as the range, hash, to improve the performance and manageability, okay? Now it is useful for large database where different section of data need to be stored separately, but within the same logical database. Okay, so this is point. In shredding, you are storing as the different databases or kind of which finally logically will get merged, but physically it's stored differently. But for partitioning, it's storing in a single space, but logically it's another separately they are storing, separate table they are storing. Okay, and there are majorly 3 ways. There are multiple ways, by the way. I'm just scratching maybe the surface. So there are mainly 3 ways of achieving this partitioning. First one is the range partitioning, which is divide the data based on the range of a volume in a column. Then the list partitioning, which is the data is partitioned based on the discrete values, like different values, like that way. And hash partitioning, which is distribute the row evenly across partitioning using the hash function. Okay, now maybe in a different session altogether, I will go much deep in this partition, all that. Going in this session, it will make it more bigger. I don't want that, but just know for now that if you want to achieve the database scaling, there is shading available, there is replication available. And by the way, I'm already working how many years? I think 14 years total experience. I have already seen shredding, replication, and only one project I have utilized this partitioning. Again, the DBA engineer was there anyway, but I was handling as a DevOps engineer all the optimization, all that. Okay, so those things are there. You need to be aware of that. Okay, and what are the like DBs natively support the partitioning? The DBs like MySQL, Oracle, PostgreSQL, it support the range, list, and hash partitioning. Okay, so this is a good to know thing. If maybe you are just junior engineer, or maybe you are the fresher, right? You need to know about all this kind of stuff, because if you go try to scale your application, you're adding more instances in the application, fine. But you see the performance is coming, the data not getting saved properly, there is the query taking a lot of time. You have to implement all this mechanism to achieve the real scaling for your application. Okay. Now I talked about the compute scaling, I talked about the database scaling. Now one thing you should know, that what should I talk about? It's about storage scaling, yes, because ultimately you're storing the data somewhere, right? And somewhere in the sense hard disk or maybe SSD, like solid state disk, right? So all those things are getting stored. Now with advancement of the technology like AWS S3, and there is many such database services, not database, the storage service available, which make our life easy. But it's good to know in the storage scaling also, there is vertical scaling, which is about adding individually, for example, one scale, the storage unit, you are upgrading that one. Horizontal scaling, same, just like you are adding for compute, you are adding instances, here you are adding the additional storage units. Another technique like this to scaling, just like compute, the vertical scaling is there, the horizontal scaling is there, but there are at least three basic techniques I will ask you to. It's not like that you can achieve the scaling, that means you should always keep adding data or you should never no. This is not how the real life works. This is not how production system works. Okay, production system data storage means cost. It costing money to store the data. The more data you store, it will cost more to the client. The less data you store, of course, less data to client, and fetching the data, manipulating data easier if you have less data. So your aim should be always achieving the less data, storing less data, and processing less data. Okay. Now, what are the best techniques you can utilize to minimize the data part, okay, or data load part? I will say the first one is the data achieving. Now, identify the data which is really getting utilized. Maybe like 40 days old backup log data, maybe for kind of very old backup data of databases, which company policy asking you to store somewhere, but you don't have any requirement, any use case of those data. Then those data should be archived and getting stored, maybe services like say AWS S3 Deep Archive, where the cost is cheaper and all the things are cheaper, right? So those things you should try to achieve, try to do to archive the data and reduce the billing. Then tied storage, for example, and this is very and actually have implemented this tied storage for one client. The client requirement was that Sandip, we have the video data, the smaller video data bit rate, which people sometimes want. We don't want that to be always available. The people usually prefer the 180p, which is very standard, but we need to keep store of that 480p, and this is very small files, so it will not take that much time to retrieve quickly. So what we did, we stored the lower infrequent data, which is required anytime customer want to give it, in a less costly place. Okay, for example, you can think of HDD. Okay, and the 180p data and 4K data, which require faster retrieval, and it has to be like snap, it has to be played when the customer want, you have the good data connection. Now those cases we have to make sure that the data comes and delivered really fast. So for those cases we had maintained the proper standard storage, so that it will be faster, and even we make sure that the IOPS also higher if it wasn't served from the EBS or maybe a hard disk, for example. It's stored in S3, so the S3 standard class. Okay, based on where you're storing the data, I'm selecting the better class for the data, particular video data. Images, they want some, very rarely people are using the images, so stored in a kind of very infrequent data access. Okay, for example, you can think of storing in HDD where the cost is way cheaper. So this is called a tier storage based on the client requirement. Usually it's the business requirement or client requirement. You have to utilize a strategy which will help you kind of reducing the cost and accessing the data faster based on the requirement, right? The third and most important, I will say, it's about what? The data lifecycle management. Now, if you are a for example company which storing and processing the logs data, okay, your application could be external application, it's up to your business model, or maybe some kind of data which just require for 30 days. But if you don't delete the data after 30 days, it's storing. Ultimately, maybe some terabyte or petabyte of data, it will accumulate, which will cost you definitely fortune. Okay, no matter you are running kind of in your data center or you're storing in a S3 kind of service or any external service. The best way is to not store that much of data if it's not required. You should have, if it's required, do the archive. If it's not required at all, have a lifecycle policy. Like if you have a certain data which is not required after 7 days, have a lifecycle, have a ETL, have a kind of auto expiry of the particular data, auto removal of the data after 7 days. If the data is not required after 30 days, set a lifecycle policy that after 30 days it should get removed, and all the major service provider, for example S3, even EBS, all this kind of services, or maybe whatever the cloud service you're utilizing, or if it's a data center, they should develop your own kind of logic there, should remove all the data. Okay, that has to be there to achieve the real auto scaling. Again, as I say, auto scaling is not just about the resources, it's also about the optimization of your application, your code, your data, every single thing in your infrastructure. Okay, so that's about the storage scaling. Let's see if anyone have any question between, otherwise I will move to the next part, which you like, which is again a very easy one. Oh, good question. Let's see. One question from Simran: we have to choose partitioning etc on the basis of like, do we like Dynamo, SQL, or not? Right, right. Based on your, see, based on the table type that you want to achieve, or based on the data that you're storing, it's the separation you have to make based on that. Based on most cases, based on the unique key, you do this kind of partition, okay, or unique data type. Now, from Ankur, what type of data should you use for write heavy app? For example, say 10 million writes per hour. Okay, those kind of data, I will suggest a NoSQL database, because schemaless you can add more shredding, add more replication, both possible these days, and you can refer to Google model or WhatsApp, their architecture. Even I was thinking of doing the architecture discussion when I get time. I was overloaded the work, but when I get time, I was thinking of having a discussion on this entire architecture, how they're implementing, what are the stack behind that, how they're handling. I will plan some kind of live session on that. But yeah, to answer your question, Ankur, if you want to have 10 million writes, you should have a NoSQL data. Again, I'm not saying it is not possible to with the like relation databases. It's possible, but that will be on the proprietary side, like Google Cloud SQL services, where you can achieve, because there. But if you are thinking of managing by your own, I will suggest maybe MongoDB with shredding and application. You can try that. Okay, and there are similar service of similar software. Even if you go to, I don't know, I would maybe at the end I will go to CNCF. I will show you there are certain services, cloud services, which is natively supporting. If you're planning to run in the Kubernetes cluster, or maybe at auto scaling virtual machines, there you can apply those kind of database services, which you can scale, and it's not proprietary, so it will be cost saving. Okay, how does the replication work during the DB scaling? So when how the replication works, so the main let's come to the database scaling. Okay, so the replication part, you have your master node, okay, or master virtual machine, where the read happening and sometime write happening. Now, when the like say the scaling means the sense when you are adding new writer node, okay, in those case you are adding newer node. So but the data that the volume, ultimately this is the database engine part, and this is the database storage part. So database engine have a storage place where the data getting stored, right? You should have a common volume. You might have one server, you might have 10 server, you might have 20 server. So all the servers are writing to a single elastic kind of storage service or volume, where you can add more servers and they will automatically have the access to that particular volume, and everybody writing there. Of course, this require the database engine to be smart about the locking mechanism also. It's not easy to achieve. Only few databases like MongoDB, I think, support that kind of mechanism. And I think another one was the Cassandra. Those kind of databases natively support those kind of mechanism, when you can have multiple kind of writer nodes and you can achieve that kind of scaling. Okay, which is ultimately like common volume. All the master node writing the common volume. That's how you are achieving the master writing part, writing synchronization. And for read replicas is very easier. Like all the read replicas copying from the common volume. So you have a common volume, you have all the data getting replicated to all the read servers. So that's not a complicated part. Complicated part is a kind of scaling the writer node, because writer node has to write continuously to the volume, right? A common volume. And the locking mechanism, if it's not proper for the database engine, it's bound to fail. That's the complex part. Okay. Let's see. Yep. Okay. Feel free to keep asking question. I'm loving this kind of question. Okay. Please, sir, can I see the previous PPT? I think this is the database scaling part. This is the compute part. And again, don't worry about the PPTs. Like, PPTs are like this. I was thinking of I have kind of notepad ready. If anybody have any question, you want more detailed depth in discussion, I will happily explain in the whiteboard. Okay, so don't worry. For now, just let's focus on the conceptual. If you have any question related to the conceptual part, I will happily explain and go very deep into it. So feel free to ask the question, and I will definitely answer the scaling, any question related to the scaling of any kind of scaling. I'm not just talking about the database or storage. I'm also talking about the network scaling also. So let's talk about that. Network scaling. So what is, I mean, we talked about the compute, we talked about the database, we talked about the storage. Now let's talk about the network scaling as well. By the way, before I start, I have YouTube folks running and watching so many YouTube folks, but LinkedIn coming are coming more. So if your folks are watching YouTube, watching on YouTube, you should ask question on YouTube also. Okay, now I said that. Let's continue. So yeah, now imagine this. Okay, you have an application. Okay, I will come to this bandwidth, load balance, Syrian. As I say, I will go in depth about load balancing and Syrian, right? While discussing at the initial stage, I will come to that. This is the part where I will go into very kind of very in depth. Now, let's talk about the bandwidth part first. Okay, and this is very interesting one, and very less people, I think, kind of aware about the bandwidth part. Even sometimes I talk with a senior engineer, he's like not even aware of the bandwidth part, which is very crucial, by the way. Now, think about EC2 in if you have worked with EC2 and maybe any cloud, and maybe in data center also. When you select a virtual machine, you get a network connection. Maybe it's a 5 GB speed or 10 GB speed or 1 terabyte speed, based on the amount that you're paying for the instance class that you're selecting. You have that bandwidth. The more you pay, the better class you choose, the upper class you choose, based on that, the better bandwidth you get. Okay. Now, think about, you have a small application. You're a startup. You're working for a startup company, or you're a startup company. I don't know. You're the owner watching, or you're the engineer, but whoever watching, you have a startup company. You have a small application you're running. Now that is okay. You have maybe 100,000, 2,000 user base, not much load, right? Whatever virtual machine, 10, 20 kind of virtual machine, whatever you have, that's fulfilling his thing. You are growing as a startup. You're becoming a full firm company. You're becoming a larger startup. Okay, like kind of Uber, kind of, or for example, bigger company. You're becoming bigger. You have very good demand. Can you think of like the instance type that you select, the virtual machine you've selected, the maybe the bandwidth was maybe 1 GB, 2 GB, what Gbps was there? It was enough for 2,000 users when they're making request. When it reached to a certain point, when you're making part, as I say, someone question like a 10 million request coming in 1 hour, is that can serve a 10 million request per hour? I don't think that's possible. 10 million requests coming, a particular internet bandwidth having only 1 GB or 2 Gbps cannot support that. You need terabyte, like 1 terabyte of speed or 5 terabyte of speed, that kind of bandwidth, like the instance that support or connected to that kind of network or bandwidth. You need to select those virtual machine. So that's why selecting and doing the bandwidth optimization also required if you want to. We are talking about scaling, right? From 100,000 or maybe 1 lakh, 2 lakh to millions of requests coming. Those kind of scaling if you want to achieve, it's not about the compute, it's not about the database, it's not about the storage. You have to think about scaling the network bandwidth as well. You don't have a shortcut. These are all operational cost. If, for example, you are making 1,000 rupees profit of 100 user, you are making that profit will multiply. If you have lakh user, you have 2 lakh user, 3 lakh, right? Based on the user. So that same way, the cost of running a business will increase. Because of the resources that you already have, you need more resources to kind of handle more clients, more users. So of course your your resources cost, your compute, your storage, everything cost increase, and so your bandwidth cost. So usual cases, you can go for custom bandwidth. I think most cloud have those kind of thing. But in general, you select the virtual machine which have a access to, or which have attached the better internet connection or better bandwidth, maybe 1 GB or 1 Tbps or 2 terabytes kind of terabyte per second, or not terabyte, I think gigabyte per second. Okay, I think but see the it depend, because customer to customer, based on the application workload, you have to select those kind of system. Okay, you can just go to AWS. I will show at the end of the, maybe just after a few slides at the end we'll discuss about the bandwidth part, and I'll show there are different instance type with different bandwidth connection. I will explain that part later on, so don't worry. For now, think about that. When you are scaling, you have to, if you are scaling too much, or if you have a too much scaling requirement, like for example that 10 million request coming per hour, then you have to of course select the better instance type or better virtual machine with better bandwidth connection. Okay, that is a requirement. Now, and yeah, another optimization, I think, yeah, load balance. Let me quickly check. Okay, increase the overall capacity. Okay, yeah, load balancing part. So, what is load balancing? Now, load balancing is the process of distributing incoming network traffic across the multiple servers or network paths to ensure no single server become overwhelmed, leading to improved performance and reliability. Okay, and types of load balancer: hardware based load balancer, software load balancer, and software based load balancer, and the DNS load balancer. What are the hardware? Maybe we have physical device which distribute the load. There are, you can think of a router, I can say, but there are different kind of individual device available which do this kind of load balancing for internal data center. For software load balancer, I think software based load balancer is Nginx, HA proxy, those kind of available. DNS, which is, you have a DNS service which do this kind of load balancing. Okay, understand the load balancing algorithm, and then I will go in a note, I will explain a very in depth on the load balancing part. Okay, so what are this load balancing algorithm? There is three very common load balancing algorithm available. The first one is the round robin, which distribute the request sequentially across the service, all the server inputs. So round robin in the sense, you have maybe 100, you have 100 virtual machine, and there are many requests coming, maybe 100,000, whatever number of requests coming. You are one by one, kind of sequentially, you are distributing the traffic between the different instances or virtual machine, that you are calling the round robin. What is the least connection? And it's very very common one, I will say, which is direct traffic to the server with the fewest active connections or fewest load you can think of. For example, you have 100 virtual machines, a new request coming, you see which server has the least connection, or identically thinking it's the least loaded server, direct the traffic there. So instead of directing the traffic to a loaded kind of virtual machine which already running too many active connections, forward that to a connection, forward to virtual machine which have a less number of connections. Okay, that will be, the load will be lower, right? And the next one is the IP hash based, which is like distribute the request based on the client IP address, ensuring the client consistently connect to the same server. For example, we have again 100 server virtual machines available, and once the request come, that request is, maybe he is connected to a, for example, instance number 10 or 12. Next time he disconnect and connect back, he is coming to the load balancer. Load balancer will redirect his traffic to again to the instance number or virtual machine number 10 or 12 where he was previously connected. That we are calling the IP hash based load balancing algorithm. Now let me explain the load balancer very depth. I think this is key concept if you are to become better cloud engineer or DevOps engineer or whatever it is you want to become, assistant SRE if you want to become, okay, or platform engineer, whatever it is. Okay, one question is there from Pavan. Will slide be shared? I mean, I always share the slide, man, free of cost to everyone. You will have it, don't worry. Okay, so for example, user, so many user. Okay, I'm talking about the scaling, right? Why only one? So many. Okay, so many users, and they're connecting. For example, if there is no load balancer, how that looks like? A single server with maybe www dot something is there, maybe REST API, or maybe dot REST something is there, okay, and all the requests coming to there, ultimately to the server, like this coming to domain forwarding the traffic to the server, okay. Only one server, or maybe one server, I mean, load with a load balancer you cannot like read the traffic to so many virtual machines, right? So in that case, if too many people coming and requesting, this will be overloaded, like not be able to serve any more request. And that is the reason we have the load balancer. On the other hand, okay, so you have again too many users. I'm a very good drawer. What do you have to call it? Okay, so many users, it's coming, and there is a load balancer in between. Okay, load balancer. What it does, it have the pool of different virtual machines. We have so many virtual machines. Okay, let me drive so many virtual machines like this. Okay, we have so many virtual machine. It checks, and again based on the algorithm, it checks based on which algorithm. It could be round robin, which is based on sequential one by one. It could be the least workload, whatever server available, or it could be IP hashed based, like connect to whatever connection previously had. Ultimately it will distribute the traffic. So many traffic coming, and it will distribute. Okay, all the traffic will distribute accordingly to the different virtual machines, like this. That way, it's not a single machine get overloaded. Everybody is happy, right? And in addition to that, you should have autoscaler. I mean, just I'm giving as an advanced kind of guide. So autoscaling. So based on like the CPU or RAM or active connection, okay, like based on number of people, active connection, it should add new virtual machines. New virtual machine to add, and once that get added, this will get registered in the load balancer, and then load balancer will forward the traffic. Okay, like that. That's how in real life scaling works. It's not scaling, I mean scaling of course, but the load balancer works like that. Okay, so that's why you need load balancer. Okay, now I'm saying you need load balancer in a presumption you really have that much of workload. For example, you want a monitoring dashboard which only maybe you or only 5-10 people want to kind of access it. It's okay for that to avoid the load balancer to save the cost. But if it's like so many people, millions of people kind of accessing the API, a service like that, then ultimately API or service, whatever it is, then you need this kind of architecture where a load balancer should be in front of the private instance, the particular virtual machines. It will for distribute the traffic between the virtual machines. That's how should be the ideal architecture for the scaling. Okay, now that's what I talk about the load balancing. Okay, now what is a kind of CDN? Let's talk about that also. CDN servers. Okay, so before that, let me see if any question I don't want to make anyone feel like left out. If any have any question, I want to answer them. So let's see. By the way, I'm going to cover the Kubernetes advanced scaling topics also. So stay on if you are interested in the Kubernetes part. I keep it at the very last because that's the most interesting one. Okay. Now from Jagdish, he's asking, can we attach additional bandwidth without changing the instance type? Something like using ENIs. That is possible. I think there is in AWS or any cloud service provider adding different features. I think it was not there many years back, but I think that's possible. I also have to check it. I also forgot. But when normal cases I was doing the upgrading of the instance type, I had to change the instance type. to a better one. Okay, of course that kind of instance have the NVIs, better storage, better SSD and all that. So altogether it's not about something only the bandwidth, but overall it's the best package for the scaling part we have utilized. But yeah, I think I have to check myself also about the ENA adding part, but in general you have to change the instance time. Okay, that is the common part. You have to check the advanced part later on. But anyway, that's a good question. I also have to check it. I also forget. Any other question? Let me quickly check. Nope. YouTube. I think YouTube, no question. YouTube is getting slower these days. Okay. Now let's talk about the CDNs. So what are CDNs? Now CDN are a content delivery network. Is a system of a distributed server that deliver web content to the user based on their graphical location. Okay, and the origin of the web page and the content delivery server. I'm going to talk about that. Okay, let's again come to the our best explanation part. Okay, let's create a new page. Okay, so what about this CDN? CDN, content delivery network. What is it is? Okay. For example, you are a user, okay? You are a user. You have a phone in hand, okay, or tab, whatever you want to call it. I'm drawing phone, but you can think of it as a tab. And you are watching a web page, okay? Okay, you are watching a web page in the tab. Now, that web page, of course, is pulling resources. Maybe the web page is actually in the US server, okay, or maybe in the UK, or maybe in the Australia. You don't know from which part of the country or which country you're getting the traffic, right? Usually you don't know. But if, for example, you are from India, and if this server were from the India, the latency, the speed, everything would have been faster. Like there should be very less latency, right? And that is why we have the CDN. CDN are in place. Like you have, like you are a guy. Let's again, I'll just draw here itself. So you are a guy who have a phone or maybe tab, whatever you want to think of, a web page. First time, if you see, they have a local, for example, in India, you are from India, okay, or maybe whatever country you will think of, and the same country you have the local CDN server. So you call it CDN server, okay. That page may be in the US or UK, but since you require it sense that you are from India and you are pulling the data from US, the page pulling the data, maybe video, maybe whatever the content it is from US, then it will store a copy in the local CDN server. In India, if they have a CDN server or CDN, you can think of CDN server only. Ultimately, they have to store somewhere as CDN storage page. Now, next time you request the same content, the request not going to here is getting served from here. So ultimately making it faster, the content getting faster, you are happy as a customer. For example, if you're watching a Netflix video, for example, okay, and it's loading like hell. I mean, you are watching a Netflix video and it's taking just 5 minutes to buffer that. It's so bad, right? You don't want that way. So if you have a CDN server, that will help you stream the data faster, the video faster. That's why we have CDN server all over the world. Okay. Now let's think about whatever the CDN solution you have. You have the Cloudflare, you have Akamai, you have AWS CloudFront, which is a very common one, Google Cloud CDN. You have all these CDN services which bring you this particular facility. Okay. CDN server are good. I mean, it's very not that costly. Okay. Of course, there are many scenarios which can make it costly, like cache invalidation. If you have many kind of a huge amount of data storage in CDNs, all that ultimately. But if you are storing that much of data, you have that much of customer. Of course, that means you have that much of sales and money, right? I mean, income coming. So just fine. If you have the money it justifies the cost, is fine. If it's not justifying the cost, it's useless. Okay, this is the last scaling technique I'm going to talk about. I'm going to talk about Kubernetes scaling and all that, but that's a kind of additional scaling technique, I'll call it, or additional scaling. But core scaling level, I'll call it API scaling also. Okay, and there is a many reason for that. So okay, API scaling. When I'm talking about the API scaling, what you can think? That means no matter it's a 1,000 API call, it's a 1 million, 10 million API call are happening. How? Okay, do you need to do mind? Okay, let's see, Sadish Kumar, do you mind application B? It depends again. All depends based on the application architecture. It's stateful or stateless. It depends. It's all based on the application. Scaling part also. I mean, if you have a requirement of stateful or stateless, based on that you should be selecting. Okay, all that based on that. Okay. Now let's talk about the API scaling. Okay. So what is API scaling? API scaling, just as I said, I think I'm just reiterating, but just bear with me. It's about no matter you have 1,000 API call, 1 lakh or 1 million, the API services should not go down. It has to serve that request. Okay. Now, what if it is an attack? It is a DDoS attack, or it could be any such scenarios, right? You always have to keep in mind all those kind of scenarios while designing the API and scaling. So when the kind of that much of scaling, I mean, requirement happens, you need some certain strategies to handle that sudden workload or maybe pre-planned workload. Okay, these are the strategies. The main two I'm going to call it rate limiting and throttling. These two might look kind of same, but it's different. And as I explained, you will get a better understanding. Okay. So what is the rate limiting? Rate limiting control the number of API call a client can make within a specific time frame. It prevents a single client from overwhelming the server. For example, I am a client. Okay. I am calling the Google APIs or maybe a certain API, or whatever APIs you are developing. I'm calling the APIs. Maybe I shouldn't be calling your APIs in a minute for more than 100 or 200. For example, this is also inhuman. Like normal cases, I'm making an API, I'm using an app and API making API call. It should not be in a per minute more than 100 or 200. Okay. What if from me I have developed some certain, I'm a hacker and I have developed certain kind of script which make 1,000, 2,000 or maybe millions of API calls to a particular API. Then the servers behind that API will get overwhelmed, will get service will be like, it will be denial of service attack, some kind of, right? That should not happen. And to do that, we have a very good strategy called rate limiting. And all major programming language packages have this package rate limited. You can even, I have implemented my own custom rate limiting for my clients also, which is very easy. Based on either IP, based on user session, based on like user ID, based on the API keys, you can achieve this rate limiting feature or rate limiting strategy, which makes very clear to the client that see, you can make 1,000 requests in a 30 minute, 50 minutes or 1 hour time frame. You cannot make more than 1,000 API call. And if you make more than 1,000 API call, then you will get a very good error called HTTP 429 too many request client error. So and this is okay. I mean, for example, you are a product company, you have developed an app and you're running the app for maybe already 1 year or maybe few months. You know the per user from monitoring from analytics, you know how many API calls a user can make. Based on that data itself, what you can do, you can add this kind of rate limiting. If a user making in a minute or maybe a 15-minute time frame more than 200, 300, maybe 500 API calls, it's look like it's not a real user. It's script, some bot making this kind of API calls, and that's how you can block it by throwing an error HTTP 429 using whatever programming language and you're utilizing, and it will give the error and ask the user to stop making request. You can give like what is the next time you can make the request. Those kind of data, if you want, you can supply. And sometimes what happen, if you kind of give that data, then the script read that particular data from the node and then automatically retry after the time. So you can give based on your, if you're confident in your services, you can give or you can skip that part. So that's about the rate limiting. You're stopping that. you are not allowing them to make any request after a certain hard limit. Okay, that is called rate limiting of API calls. Then what is the throttling? Now, throttling is very unique concept. Okay, so throttling is a practice of reducing the number of API requests a client can make once they exceeded their rate limit. Unlike the blocking request, throttling delays the response or reduce the request rate. How it's very very unique. Say you have API classes. Okay, to think of like you have some strategy. You have good servers, you have cheap servers, you have bad servers. Okay, you have like to save the cost, you're running some servers in a spot instances. Okay, you can think of, and if to for good customer, good client, premium clients, you have a normal cluster, which are on-demand cluster. Now, if anybody making too much request, forward the traffic to the bad cluster or SWOT instances, something like that, which is cheaper, which is and slow them down so that they will feel the API response taking too less, like too much time and all that kind of way. Okay, so it's like, for example, I'm giving you another good example. You have heard about the mega upload and all this kind of file upload servers, right? Where you want to fetch the data. I mean, you have a file you want to download from, maybe 1 GB file you want to download from a mega upload or this kind of file server, download server. You have an option for premium download, or you can just wait for 28 second or 30 seconds, and then the download also happen. Like your data speed is 1 Gbps or maybe 100 Mbps, but it is downloading the data like 1 Mbps speed, so slow. That is a strategy of kind of throttling. So they're throttling, they're not giving you the full fledged capacity of their servers. They're knowingly throttling or serving the data or request from a poor server, very less resource request server, or maybe slower server. Okay, or maybe they want you to wait. By in the code they have mentioned send the response only after certain seconds or minutes. So that is a throttling, which make feel the attacker or some kind of that something gone wrong. They will be happy, but ultimately for good customer, the API response coming very fast. For bad like this, who already exceeded the limits, they're making too many requests to the API, their response getting slower. That's called throttling. Okay, now, what are the different other strategies? These two are rate limiting. I'm implemented for all my client. Throttling I sometimes implement, sometimes don't. But rate limiting is more than enough for me. Sometimes it's throttling because they don't want to disrupt the services. They want to give the services, no matter bad actor, good actor, but they want to give the services, but want to throttle based on the client requirement. We have to make the choice. Then what are the other strategies? Of course, load balancing. By now you know how to do. How I mean, I explain in greater depth. Failover mechanism. For example, you have one server which is a good server. Somehow too many requests came that gone bad. You should have a backup server. Automatically, the failover should happen to the new server. I think most of the cases, in case of auto scaling itself, if you have a load balancing altogether, if a bad server is there, it get terminated and automatically the new traffic come to the new server, and new server automatically get created also. Okay, so you can think of that strategy. The third one is the circuit breaker. What is the circuit breaker? It temporarily block the traffic to the failing service to prevent. For example, you are running in a microservice environment and you are kind of stopping. I mean, one microservice is not working. So instead of just keep the client waiting and waiting, that service is down, then and you have the circuit breaker in place, just checking the service is down. It can of course have auto healing and all that kind of stuff. If the auto healing is not there, it may be taking time. Give the error like something gone wrong. It's on progress, getting solved. That's how you can prevent the cascading of flares and allow the recovery to happen. Maybe too many requests coming, you are blocking the request so that the particular pod, a particular virtual machine recover from the too much of the load. Okay, that we are calling the circuit breaker. And then you have the API caching. What is the API caching? Now this involves storing copies of frequent requested data to reduce the load on the API and improve the response. For example, the data which is not changing too much. It's a data that doesn't change too much. Okay? Could be some web page data, static data, this kind of data. Okay, so you can stored as a cache to different ways. You can store in client side, like for example, client made a request, it got the response. Again, is the same exact request, and like clients know that okay, this particular API doesn't change. You configured your application such a way, your front end application such a way, then it will not call the server from the cache. It will serve the data. Okay. Now there is the next one is the server side caching, which is, for example, you have static HTTP pages, okay, that is stored as a cache. So instead of generating a new page or serving a or new page, new HTML content, it will serve from the already pre-generated HTML cache. That way it will kind of serve faster. Then we have the reverse proxy caching, which is uses the reverse proxy caching process like Nginx server or maybe Varnish to serve the content, okay, which is again a faster way based on the newness of the data or maybe the data type. You decide which kind of caching strategy you can go for. Okay, we talked too much. I mean, I talked too much, not we. And yes, we are going to talk about other popular caching strategy. I mean, not caching, but scaling strategies. But before that, let me check any particular message came. Yes, thank you. What is it? Parash Chain, I think. Thank you, Parash. Any question? I don't see any question. Okay, no question. Then that's also okay. Fine. You can. Yeah, I will share the doc maybe tomorrow, because now I already made a video. Then nobody will watch the video. They'll just go to the PDF. But it's okay. You can refer to that as a handy stuff. But all this explanation you cannot get from the PDF, man. Okay. The juicy parts, I will call it the most demanded or hot parts, is the containerization, scaling, and orchestration part, right? Okay. So first let's go. This I know, like most of you guys know what is containerization, what is orchestration, what is Kubernetes, but I have viewer who don't know about the what is even containerization, and that's fine too, because maybe they may be student, they may be learning about it, they may be coming from the other field, so it's fine. Let me first explain what is this containerization. So containerization involves packing of your application. Maybe you can think of, you can run a PHP app or maybe run a Python app in your local machine, right? Now, what if whatever the application requires, the data, the codes, the packages, and everything, I put inside some virtual instance. You can think of a mini virtual instance which already have that. So this is the containerization. We create a container package, or you can say box. In a box, we store all that thing so that we can later on you retrieve from the box and run it in a virtual. You can say some kind of virtual machine. Okay, so this process we call virtual containerization, where you containerize, you contain your application codes and all the configuration in a package, in a portable package which can run from another virtual machines. Okay. Now, why this containerization part? Why it is required to achieve the resource efficiency? But like if your virtual machine have five CPUs, 10 CPUs, maybe 20 CPUs, when you're running a single application, it individually may be utilizing only 1 or 2 CPU. But if you run smaller containers per code, per CPU code, or maybe millicode, whatever you configuration you do, then you are utilizing fully every single bits of your CPU, right? That is what you're calling the resource efficiency. I'm giving a CPU example, but it can be RAM, it can be storage, it can be any compute or any comparable compute. Okay. Then the consistency. Since you're storing, you're running a small virtual machine kind of stuff from a copy, or it is exact copy. When you run containers, you run exact copy of container images. Okay, and so this way you are achieving a consistency. Like one container image of same tag, same repo name will not be different when you run in another virtual machine. It will be the same thing, right? Now, based on the configuration, it can be different, but the code, the packages, and everything, it should run exact same way, right? That you are calling the consistency. Portability. If you create a container package, you can store the container image in a remote repository or in a remote server. And for example, I'm storing in a remote server. I want to next day run in my friend machine, in my another server or 20 other server. I can simply do that by pulling the image. Okay, that giving us the portability. Then is the isolation. So each container run its own isolated environment, reducing the conflicts and improving security, specifically the multi-tenant environments. Okay, so that is another important part. That is why we need containerization. By the way, containerization, we can have Docker. I mean, these days people are not even using Docker that much. They're using other container RB, even I think cronj. There are many other services. I'm going to make a video on that. You don't need a Docker. There are many other services people are actively utilizing to create the images. I may cover that in my later future videos, not right now. Okay. Now, ultimately, you have a container, but when you run a container by yourself, fine, you can run one container, two container, 10 container, you can manage. But think of a situation when you have 1,000 container or 2,000 container, or where I'm handling maybe more than 1,000 containers. Okay, manually handling impossible. It's beyond possible. Okay, you cannot do that. You need a container orchestration tool which manages these containers, their life cycle, their organization, the pod to pod communication, the networking, the scaling, every single bits of it. That's why we need an orchestration tool which does all this job. So like what, of course, achieving scaling, we are talking about the scaling achievement part, right? So how it work, how it help, it give the automated scaling. Like for example, Kubernetes can automatically scale scale application up and down based on the demand, adding or removing containers or pods as needed. Then load balancer, Kubernetes have very native integration. It have its own native load balancer, or you can have additional package based load balancer, or maybe external load balancer, whatever the case. But Kubernetes have very tight integration with that, which help you to achieve the load balancing. Self-healing, for example, one pod goes down, if you have set properly the configuration in Kubernetes, it will automatically create a new pod. Okay, which ultimately helping you to have a self-healing kind of thing. Okay, then service discovery and networking, it automatically assign, like this Kubernetes for example, automatically assign IPs to container and manages the communication between the containers, simplifying the network management at scale. Now, what I have failed, like I'm a very early adopter of Kubernetes. At the beginning application, it was not a problem. Somehow I managed. But when I worked for many bigger companies, larger companies, and had so many nodes, there I saw the complexity. There I saw the requirement having all the different add-ons, having different node groups, having different strategies for deployment, having a GitOps requirement, Argo CD, and all the requirements came after that. So that is the reason. I mean, at the beginning, when you start, you don't have to focus on scaling. But as you step up your learning game, you should be focusing on the Kubernetes scaling part also. And the moment I'm scaling, when I'm talking about the Kubernetes scaling, it's not about the pod scaling. It's also about the cluster scaling. All combined. It's combining the particular pod scaling, cluster scaling. Everything matters. Okay, so some very key points while you want to work in the Kubernetes scaling part. First thing, scaling Kubernetes cluster. And I think to achieve the Kubernetes cluster, there are many ways. And the out of those many ways, two way I found very kind of easy to achieve and production ready. First one is the cluster autoscaler, which automatically adjusts the size of the Kubernetes cluster by adding and removing the nodes or virtual machines on the current workload. If pods cannot be scheduled due to insufficient resources, cluster autoscaler add more resources. If same way, if doesn't need, you don't need so many pods, it remove the pods and remove the cluster also if there is no load. Okay. Second one is the Carpenter, and this is the very famous open source tool, and I'll make videos also soon. It's not I'm so much busy these days, thanks to my clients. I think busy is better than not being busy. Busy means I'm making good money. Not busy, not good, right? So anyway, Carpenter is a very good tool. It's recently, I think, become general availability from AWS, because AWS is the one who developed this open source tool, which performing exceptionally well, to be honest. I want to make video sooner whenever I get a chance from my workload. And it's a high performance Kubernetes cluster autoscaler that automatically provision and scales node based on the specific. Now, if you ask me, like Sandip, there is already cluster autoscaler, then why are you suggesting Carpenter? Now, You can think of the Carpenter is an advanced version of the uh, cluster autoscaler. Why? Because cluster autoscaler always try to provision whatever the higher number of or higher instance type, higher resources. But Carpenter I've seen it reserves only the much of the. For example, you need more requirement. You have set up a smaller instance type. Then it will not just spin the bigger instance type. It will or virtual machine type. It will spin the smaller instance type that can handle the particular workload. So the efficiency and the cost management part also, Carpenter is doing its job properly, better than cluster autoscaler. But again, cluster autoscaler also production ready. If you only have set up only one instance type or one virtual machine type and have the cluster autoscaler, that's not a problem. But if you have selected multiple kind of instance type and then use the Carpenter, then it will be a right solution. Okay. Then we have the scaling pods with the horizontal pod. Now again, this is a very common practice, but I still wanted to mention this. If you are new to Kubernetes, if you're learning Kubernetes, you want to make sure that you use this horizontal pod autoscaler to scale the pod. For example, your application minimum you're running 1 or 2 pods, but when the too many requests comes, the pods CPU increase, pods memory increase, whatever the case, there should be additional scaling to handle the additional workload. Okay, that's why you need horizontal pod autoscaler no matter what you run. See, implementing is you're losing nothing, right? You don't require scaling, fine. I mean, you don't require too much nodes. It will automatically run lower number of the pods. If there is too many requests coming, it cannot handle, the current pod cannot handle the workload, then only it's scaling, right? So having it's not a loss, I would say. Then using the resource limit, and this is one of the very, like, people give so many ideas and knowledge, and even I have seen a guy who giving knowledge about having resource limit, but when I have worked the company that he previously worked on, and like there is not a single deployments YML has a resource limit. So it is easier to talk about this thing, resource limits, all these kind of tools, but it's important to implement this properly. Okay, so just not learn about the resource limit, implement it also. I will, of course, I mean, I'm planning and I have already made so many videos on this topic, but make sure when you are running your workload in a production environment, you should have a resource limit in place, so that at least make sure that it's a non-critical workload, not eating away the resources of critical workload. That is, you have to make sure. Okay. Then managing workload with label, taint and tolerances. I will not say it's too advanced, but it's a bit advanced topic where you have to make, say for example, you have for example cache, Redis cache, you have normal application cluster. Redis cache is kind of a just for the cache part, right? But if you didn't have any label, if you have no segregation between the node groups, node levels and all that, Redis require more resources for any point in time. It will eat away resources from your critical application pods, which is not ideal, right? Your application pod more important than the Redis cache engine. I mean, it's important, Redis also, but it's not that critical. Critical level application pod should not be interrupted, should not be problematic via the non-critical workload like a Redis. Okay. On those cases, you have to implement this strategy called level and node affinity and taint and tolerances. These two work together. Okay. So levels, what are the levels? Levels are the key value pairs attached to Kubernetes object like nodes and pods, used to organize and select subset of the objects. So making sure you are marking one pod, one particular node, what is it is, and making sure a pod configuration, that pod get run on this particular level only. And then what is the taint and tolerances? So you are applying a taint to make sure that if a pod's configuration doesn't have the tolerances for this particular taint, like, then the pod should not be allowed to run on this particular node group or node. Okay, that is the taint and tolerances. Okay, so that's why these two are also important. Of course, in upcoming videos, I'll be, whenever I get a chance, by the way, I'm adding that particular term, whenever I get a chance, I will definitely discuss and in more practical way. Okay. And I think this is the final slide. and I think already we have covered more than 1 hour 30 minutes. But then again, thank you for, I think so many people are watching. So thank you. This is the last slide of this particular session of scaling masterclass. I hope by now you have so many ideas about scaling and all this stuff. That was my first goal. Let's see, one question is there from Arno. I use ingress controller in Kubernetes that create an application load balancer, fine, making it the entry point. Is this the correct approach? Do I need to add? No. See, if you have one load balancer, again, load balancer, you have to make sure I will segregate based on the load balancer, which is critical and non-critical, but it's based on the use case again. Usual cases, based on the path matching or domain matching, you can redirect traffic between the different services or nodes. Okay, or not nodes, between the different services. For example, you have a load balancer. You can do the domain or path matching to, for example, slash API. It's going to the application pod slash maybe some other things. Then going to those kind of resources or maybe some kind of pods or front end, whatever it is. So that's what you can do. But yeah, adding a load balancer, application load balancer in front of a application pods is the right choice and the right thing to do. You did the right thing. Okay, I am from Jagdish. I think I have one question that I have. If have any application update based on CDN, how will be updated to the local CDN? We'll have to sync every time. Okay, it again or copy in 24. Now that again based on your requirement. If you think you need to always sync, it's a very in most cases you don't need. If it's crucial, for example, it's crucial data, you do the sync. Maybe for hourly also you can do. If it's non-crucial data that you want to sync, then okay, 24 hours, 48 hours based on your requirement, because it costs more every time you do cache invalidation. That's why you don't want to do too much in cache invalidation. Only frequently you do and do less amount of data. That is important. Okay. Okay. I think let's see. Not new questions. Yep. But okay, let's cover this microservices part. This is also important, right? So what exactly are the microservices? Microservice is pretty important and useful, and these days I think most of the modern companies running their workload in microservices. So what are microservices? Microservices is an architectural style that structure an application as a collection of loosely coupled independent deployment services, each responsible for specific business capability. Okay, and I will come to that what it is I'm talking about. And all these microservices should have a communication where, so it one microservice should be able to talk with the other microservices. Okay, and let me actually explain. I think this topic need a bit more explanation, and I will be happy to explain. Okay, let's talk about the microservice. Okay, so what is a microservice? Well, let's first another monolithic service. A monolithic service look like this. In a same server, okay, or virtual machine, you have the application, app, you have the DB, you have the cache, okay, everything you have in the same cluster, which is not the right choice for most of the architectures. What you really want is this. So for example, you have different, I mean, in a large application, I will say large because I mean smaller application also, you have your app, okay, you have like one segregation, okay, only run app, okay, app containers, okay, you have another one that only run the maybe DB, okay. These are all microservices copies. Like ultimately this is the microservice service, and these are the pods running inside that microservice, okay. This is a service, okay, and this is a service to service communication happens. It's like app talking with the database, and database giving responses to the app. Very easy comparison I can tell on that part. Okay, now in even modern approach, modern day, you have like this. These are all service. Okay, service and service. Okay, you understand these are service. Okay, and service have pods. Let's draw the pods. All the pods. Now this is a, for example, application service. This is the DB service. Okay, this is the cache service, and this could be Elasticsearch, for example. Okay, yes. Now application, or maybe another application could be there. Okay, another app, for example, another, it could be a Node.js application, one pinch maybe payment service, and this is the, for example, for web, you have, for example, this is the Python for payment service. You have the app for running in the Node.js. Okay, Node.js, and maybe you have some XYZ service running in maybe other service. Okay, so those are the different services. So each service should be able to communicate with each other. Okay, and that way, for example, your now this is important. Okay, not, for example, one service, one pod fail, you have other pods which kind of compensate. Okay, auto healing are there, no, because you are configured properly. But this is a normal architecture. This is very simple one. If you just look for sorry, my daughter is making too much noise. She want to meet me now. I think I have to quickly finish up the session, unfortunately. But yeah, but you understand the microservice part, right? So many microservices you're running. It could be services. Like each service will have different same kind of pods, so that one pod go down, other kind of service in a Kubernetes point of view. Just to give you an example. Okay. Now in this architecture, app, then there is app is kind of communicate with the cache, app can communicate with DB, app can communicate with Elasticsearch, app, Node.js app can communicate, Node.js app can communicate with the Python app can communicate with the Node.js app based on the requirement. Okay, so, and this is a very common architecture. I'm not giving any artificial or any fictional. This is very common. I have implemented same, even more complicated architecture for many clients. Okay, so in those scenarios, okay, you have to handle all this complexity, right? The communication and all that. How to achieve that part? That is important. So for that particular requirement, we have the service discovery tool. And what are these tools? So this service discovery mechanism or tools allow microservices to find and communicate with each other dynamically, especially in the environment where scale up and down happen frequently. For example, Kubernetes scaling, right, where it can happen based on the workload, right? So what are these popular service discovery tool? First one is the console, then is the Istio, and then of course Kubernetes have its own service discovery tool. Okay, so console, let's talk about the console first. Console is a service mesh and service discovery that provides a registry for services, enabling them to discover each other by name rather than the IP addresses. Support health checking, multi data center deployments, DNS based service discovery, ideal for cloud native application where the services are constantly changing for multi region deployment. Okay, then the Istio is a service mesh that provides service discovery, load balancing, security and monitoring microservices. It support the traffic management like advanced routing, retrace, and specifically the security, which is the MTLS. Okay, again, I want to cover a separate session on MTLS and all the advanced topics with practical implementation. Not today, but think those are the things that there exist, and those many company kind of care these days. Okay, and then observability like distributed tracing, distributed tracing, metrics, and all that. Best suited for complex, just like the application I've shown you right now here. This kind of complex requirements, Istio is the best choice. Okay, then Kubernetes service discovery, which is Kubernetes has a built-in service discovery service through DNS and environment variable, allowing service to find each other within a cluster. It automatically registers and deregisters services as pods, as created or destroyed, providing a simple and native way to handle the service discovery. Okay, so those things are there. This, I think, Istio is the, I think, by far most popular these days, and most of the companies who are handling the Kubernetes workload utilizing that. Okay, now let's talk about the what are the common communication protocol it utilizes. gRPC is the, I think, these days the most common communication protocol, which is using the gRPC is the high performance open source RPC, which is a remote procedural call framework that uses the HTTP2 for transport and protocol buffer as an interface. Again, you are not understanding fine. When I cover the gRPC, it's a separate video. I will explain even more, or you can, kind of research your own. Okay, that's even better. Then REST, again, I think most of you already developed the REST APIs, so you have some idea, which is the REST stand for the representational state transfer, is an architecture style for designing network application relying on stateless and client server communication, typically using the HTTP. And then I think another very common these days messaging, which is messaging queues like RabbitMQ, Kafka, AWS, SQS, which facilitates the communication between the services by decoupling the sender receiver. Here, a specific system available, which is the pub sub mechanism, where you're publishing like topic based. Okay, you have a topic, then you can send the message to topic, and whoever subscribe the topic or listening to the topic, which will get the message. For example, you're a DevOps engineer, right? So I'm a DevOps engineer. When I publish a DevOps topic, you guys are watching the topic, right? Similar kind of concept. Okay, so you have that kind of requirement or decoupling of the services. Then messaging queue also something that I want to cover in future in more depth. So let's see, when I get chance, I will definitely do. And you see, I don't have much time left. My family now, daughter specifically, she want me now. Okay, so I hope that I will to explain scaling in very good. I think it's already around 2 hour session. We have covered the in very detail. So I think that's it. I will share the slide maybe tomorrow when I get chance, or maybe I'll schedule it for tomorrow morning 10 a.m. You guys can download it. For now, that's it. I hope you like the session. If you're new to this channel, please subscribe. If you're old, just give it a like and share with other people, whoever need the knowledge about scaling. These days, master architecture people failing in the scaling when they're trying to scale. But there are the basic scaling. You should have one instance, you have multiple resources. It's not about the virtual machine, it's about the storage, it's about the network, it's about everything all together. That's the scaling, everything together. Okay, I hope you like the session. See you soon in my next video. By the way, I still don't have much time, but I'm planning the remaining videos of the Go sessions, and so Go series, and the, I think, DS and Algo series I have to continue. So I will continue that one. Okay, so see you soon in my upcoming videos. Okay, bye bye.